Titan has rivers, rain, and seas, but none of it is water. There is a world in our solar system with clouds, rain, rivers, lakes, seas, beaches, and dunes. From a distance, that almost sounds familiar. It sounds like Earth. But on this world, water is as hard as rock, the rivers run with liquid methane, and the rain falls through an orange atmosphere so thick that the surface sits under a permanent haze. That world is Titan, Saturn's largest moon. And Titan matters because it may be the closest thing we have to a full alien planet without leaving our own solar system. Not because it looks like home, but because it keeps taking the things we associate with Earth and rebuilding them out of completely different materials. That is why Titan is so strange. It is not just another frozen moon. It is a place where weather still happens, landscapes still change, and chemistry may still be doing something important. The first thing to understand is that Titan is not just cold. It is brutally cold. At Titan's surface, the temperature is around minus 290 degrees Fahrenheit. At that temperature, water does not act like water anymore. It acts like stone. The ground is mostly water ice, hard enough to play the role that rock plays on Earth. So when scientists talk about Titan having rivers and lakes, they do not mean hidden poetic rivers under the ice. They mean actual surface rivers and lakes, just not made of water. Titan is the only place besides Earth known to have stable liquid on its surface. But those liquids are methane and ethane. Titan has clouds made from those chemicals, rain that falls from those clouds, channels carved by flowing liquid, and lakes and seas gathered near its poles. In other words, Titan has something like an Earth-style weather cycle, but with hydrocarbons doing the job that water does here. That alone would make Titan one of the weirdest places in the solar system. But Titan goes further. Its atmosphere is thick, rich in nitrogen, and wrapped in a golden smog of organic haze. Before spacecraft got close, Titan was basically a mystery behind orange cloud. Then the Cassini mission arrived, and in 2005, the Huygens probe dropped through Titan's atmosphere and landed on the surface, the first landing ever made in the outer solar system. What it found did not look like some abstract ice ball. It found channels, plains, and rounded chunks of ice that looked uncannily like river stones. The pictures felt familiar in the most unsettling way. Titan looked less like a dead moon and more like a place with a climate, a surface history, and active processes still shaping it. That is the second reason Titan matters. It is not just visually strange, it is chemically rich. Sunlight and energetic particles break apart methane and nitrogen high in Titan's atmosphere. Those ingredients then recombine into more complex organic molecules, which drift downward and collect on the surface. Titan is constantly manufacturing carbon-rich chemistry. That does not mean Titan is alive. It means Titan is one of the best natural laboratories we have for studying the kind of chemistry that may come before life. And that is exactly why NASA is sending Dragonfly there. Dragonfly is a car-sized rotorcraft scheduled to launch no earlier than 2028. When it reaches Titan in the 2030s, it will not just sit in one spot. It is designed to fly from place to place across the surface, exploring dunes, measuring chemistry, and visiting sites where organics may once have mixed with liquid water. That last part matters. Titan's surface is too cold for liquid water to stay exposed, but impacts or internal heat may occasionally create places where water and complex organics meet. If you're trying to understand how chemistry crosses the line from simple molecules towards something more organized, those are exactly the places you would want to inspect. And Titan is one of the few worlds where that story may have been running for a very long time. There is also a deeper reason scientists are obsessed with Titan. It may tell us something about early Earth. Our planet did not always look the way it does now. Before oxygen filled the atmosphere, early Earth was a much stranger place. Titan is not a copy of ancient Earth, and nobody serious thinks it is. But it may preserve some of the broad chemical conditions that make scientists ask one of the biggest questions in science. What happens before biology begins? Not life itself, but the step before it. The stage where molecules are built, sorted, concentrated, and pushed into more complicated forms. Titan gives scientists a place to study that problem at planetary scale. And then there is the most provocative idea of all. Could something truly exotic happen in Titan's lakes? This is where it is important not to slide into science fiction. No one has found life on Titan. No one has evidence for methane-based creatures swimming through its seas. That is speculation. But it is serious speculation in one narrow sense. Scientists do study whether Titan's chemical environment could produce cell-like structures or unfamiliar pathways toward complexity. In 2025, NASA highlighted research showing that vesicle-like compartments could plausibly form in Titan's lakes. That is not proof of life. It is proof that Titan keeps forcing chemistry into the conversation. Even without life, that is enough to make Titan extraordinary. Most worlds give you one big reason to care. Titan gives you several at once. A thick atmosphere, a methane weather system, organic dunes and seas, an eerily Earth-like landscape, and a mission on the way that will fly through another world's sky. Beneath all of that sits the real prize. Titan may not just be weird, but revealing. What scientists still do not know is a large part of the story. They still do not know the ultimate source that keeps replenishing Titan's methane atmosphere over immense timescales. They are still debating Titan's deep interior. For years, evidence pointed to a subsurface ocean, but more recent work suggests the inside of Titan may be more complicated than a simple global layer of liquid water. They still do not know how far Titan's prebiotic chemistry has actually progressed. And they do not know whether chemistry in methane lakes could ever approach anything we would honestly call living. So the payoff is not that Titan is a second Earth. It is better than that. Titan is a reminder that a world does not need blue oceans and sunlight to be dynamic, complex, and scientifically important. It can be dark orange, minus 290 degrees, and drenched by rain that would be a gas on Earth, and still be one of the most important places in the solar system for understanding how worlds work and how life's ingredients might assemble. Titan feels like a contradiction made real, a frozen moon with weather, a place that looks familiar and alien at the same time, a world where the shoreline is real, but the sea is methane. And once you realize that such a place exists, the next question becomes hard to ignore. If Titan is the strangest Earth-like world we know, what happens on a moon like Europa, where the ocean may be